Hello, friends. I've gotten a few requests for more information about how I build out larger projects. So I'm just going to do a walkthrough of a project that I built a couple of years ago. General idea is to give you a sense of how I lay out commercial projects. This project was for a conference setup where there was sort of a show floor area, and we had a couple of cameras set up that would track the number of people that were in different zones. And then there was a big lighting rig hanging from the ceiling that would display different types of patterns when different numbers of people were there. So when there were few people, it would be in kind of a more idle, sedate mode. And then when there were more people, it would get more exciting. This is the user interface that I built out for it. Down at the bottom, we've got a previs of what the lighting actually looks like. So this was using a whole bunch of Astera Titan tubes that were suspended from a big complicated rig. The previs here was based on just having a bunch of little dots that are the right color in the right position in space. And I added a little bit of bloom on it just to kind of make it look glowy and nice, but basically it's just instancing a bunch of dots. The interface here was designed for an operator to look at. So this is not something that like a guest would be seeing. This is more something that I or somebody else operating the system and just kind of monitoring it would look at to see what's going on currently, as well as to provide some tools for debugging issues and testing things and doing the kind of things that were needed during the setup process for the installation. So I already mentioned the previs area at the bottom. I used a camera viewport thing in here, so you can change the view there. I also added a reverse view, and this is because of where the server for this installation was located. It was kind of at the back of the event. I also added a toggle here to turn off previs entirely, just so that it isn't eating up resources when the installation is just kind of sitting there doing its thing and you don't need to like preview anything. So it just saves a little bit of processing time. In the top area here, I added this table of a bunch of details about kind of the current conditions of the system. I'll get into how this table is built, but this is basically just showing the state of the different sensors that we were using and, how many people it was currently thinking were there, what type of content it was playing currently, and things like that. The content for this was split into several different levels, and a level was basically a look, and then we would define how many people it would take to trigger that look. So when there were 0 people, it would just be in this idle state. And if there were, a lot of people, it would go up to whatever level was appropriate. So we had settings here to define the cutoff points for the different levels. So how many people does it take to hit level 4 and so on. I added this bar visualization there just as a way to kind of see how close it was getting to the different cutoff points. And we used that during setup to kind of tune those levels. So we would see, okay, this looks like a lot of people and it's currently counting, 16 people. So we'll have that be kind of the higher level or something. And then we would kind of adjust it as it went to see what the appropriate boundaries were. In these two areas here, I don't actually have the Oak cameras set up, so there isn't previs there. So this would show the camera's view of things and with like little highlight boxes around the people that it was counting. I also added a status display to each. And I added that because these cameras have to go through a startup process that takes a little bit. So I wanted to know when they were ready and also to display any situations where they ended up in an error state and might have to be reset or something like that. I then added some graphs for the number of people. So as people would show up and leave, you would see changes to this count here. So if I change it there, you'll see that it shows that and you can kind of monitor the situation over time. I would also include this state, which is basically which level of content is it currently in. Off to the side here are the values that were getting sent out over DMX. This predates POPs, so this is all still being done in shops. There are now much nicer workflows for doing that, but at the time it was all channel data, and so I just added a view of that here. On the side, there are a bunch of parameters to control different parts of the project. I have a little area here where it has buttons to load and save settings. So that basically takes all the settings that are in these parameters here and saves those out to an external file. And then it can also load back from that external file. I did that because this file is split out amongst a whole bunch of different tox files. And explaining to an operator how they would have to go about saving all of that so that it would actually persist if they change things and then had to restart the project is not a straightforward process. So I just had it save out to an external file and then read that back in when the project loads. This area is for parameters related to the sensors. So it has different settings for, like, how certain it has to be that a thing in the field of view is a person and, how long it requires them to have been tracked before it actually counts them and so on. I also added a setting here to override the number of people that the sensors were counting. So we did that for situations exactly like this, where we don't have the actual sensors hooked up, but we still want to test the whole rest of the flow of the logic and the content and all that. So I can just set it to, now there are 17 people, and everything else downstream of that will just kind of behave as though that's what the sensors told it. Then there is this section here that controls the different levels and which level it's currently in. So I also added an override here so you could manually set it to a particular level. This is a little bit redundant since there is a way to set the count, but it is still kind of useful just to have that ability. And then one kind of important thing related to those sort of overrides is that during the startup process, which I'll get into in a little bit more detail later, it clears out those enable override settings so that it by default goes back to the sensors so that if somebody is sitting there testing things and then, closes the project and reopens it, it doesn't stay in testing mode. And, that because that could be something that an operator might not necessarily notice. And it could result in the installation just ignoring the actual sensor values. Then there's a final control for brightness, so you can kind of like dim the whole installation. We didn't end up really needing to use that because we just had it operating at maximum brightness the whole time. But when you're dealing with lighting stuff or even video, it's good to have just kind of a final like brightness slider on things. I also added some testing modes, so I'll get into how exactly those work. But there are different modes that would do like a sweep along different axes. And this is really useful when we were trying to make sure that everything was mapped correctly so that we had the right DMX setup for each individual light bar that was out there. And then finally, we have a control for DMX output and then a toggle to switch that on and off. And this is helpful for situations where there were still technicians setting up the lights and I wanted to be working on the system, but I didn't want it blasting out DMX and confusing what they were trying to do. So it's usually good to have a setting for that where you can just kind of like shut the thing off, but have it keep doing its thing, just not sending anything out. And for a video based piece, that could be something like just closing the output or, blacking it out or something. So let's take a look at the actual project itself. This is a pretty typical type of layout that I tend to use for projects like this. And I use it in cases where there's enough complexity to have separate areas of the project. If it's just like a little experiment, render some cool interactive thing or whatever, like this is kind of overkill. But once you start having a more complicated system with different types of functionality in it, splitting things up into subsystems is a really good idea. And so my projects will typically have, this root component. And then within that, there will be a bunch of these sort of subsystem comps. And then on the parent component there, I'll set up operator shortcuts for those. So now anything within here can access property of the sensors by using iop.sensors. I did a whole separate video about operator shortcuts. So if you want more detail about how those work and how to set them up, I recommend checking that out. The subsystems here are organized into somewhat of a flow from one to the other. So sensors are where it's taking the data from the Oak devices and then applying, in this case, a mobile net tracker. This is largely based off of the Oak samples that come with TouchDesigner. I just customized it a little bit, but basically it's the one that comes with Touch. So I would do a little bit of massaging of the data to smooth things out. And then there are a few places where I would set up these replacements with a constant. So in the case that, something isn't hooked up, like in this case, the oaks aren't hooked up, by having a constant going into replace that just sets up a channel of the right name, then everything downstream of that can always just assume that that channel will be there. And, once it starts actually producing data, that will fill up that channel and it'll replace the kind of default values. So then this chop here with the sensor values, basically just how many guests are we able to count from the sensors currently? And that's basically the main output of this whole subsystem is just a bunch of logic. And the end result of that is how many guests does it detect? I'm also collecting a bunch of channels here that are primarily for debugging purposes. So these are coming out of the Oak operators. And this will indicate whether, one of them failed to initialize or has some sort of error on it. It also shows how many frames a second they're getting in case one of them starts lagging for some reason. And so I collect all of that into a chop. I then convert it to a dot and add some prefixes to it so that I can display this in that panel in the UI to have some kind of details about how this part of the project is behaving. This is a pretty common approach that I tend to do with these, where each subsystem will have a dot called info that has just properties of what's going on within that subsystem. And generally, I'll just collect all those together into one table and show them in the UI. This is stuff that is not like being depended upon by other areas of the project. This is basically just for debugging purposes. And some of it ends up being, duplicates of data that shows up elsewhere. But this chop is where those parts of the project go to get the guest count. They're not pulling it out of that table. Then that data and basically just the number of guests goes into this state one. And this is what decides what type of content the system should be showing currently. So there are settings on here for how many guests it takes to qualify as level 3 and so on. That all gets summed up in a chop here where there's a channel for each level indicating if that level is currently active. There is also this state index here that just says like which number level, but the active channel is just, for each one, is that the current channel or not? And separating it out into different channels like that makes it a little bit easier to just tie that into is, one piece of content playing or not. I also added a pulse for each one for when it first switches into that mode. And that's because there are a lot of types of content in there that will trigger an animation when it, crosses the threshold into that mode. And then this ratio thing is like how far is it within the range of, how many guests it counts for that level. So this is where that like slider bar in the UI comes from. Similarly to the sensors one, this also has its own info table. So that chop with all the properties of the different levels or states goes into the rendering subsystem. And to warn you before I jump in here, this is a big one. So this is it. This is not necessarily how I usually like to organize projects. So typically I'll have subcomponents where like this area, which is a particular type of content, would be just one component within that. So it kind of keeps the top level network a little bit cleaner. In this case, because of how many places we're referencing some properties like color and stuff, piping that through multiple levels ended up being kind of messy in its own way. And so this is how I handled it. So each one of these areas here is like a type of content. So this would be like, one where it kind of expands out from a point and has this sort of like wave effect. So those are typically kind of triggers for when it switches into different modes. Then there would be some, noise based blobs that float around and a bunch of other kind of just color patterns. Some of this is using RayTK with point map render, which takes a bunch of positions in and then samples color at each of those points. So all of that goes into one big composite top here. Then there's stuff for the test patterns that I was showing. So this will do like, sweeps across each axis, as well as some that would, fill in different zones of lights into different colors so that we could kind of debug things. All this is depending on a bunch of data about the arrangement of lights in the installation. So up here, I've got a bunch of these tops that have data like position in space where each pixel or LED is, as well as masks for, different groups of LEDs. There's kind of like that inner ring is like one zone, the outer rings are another zone. And so those masks are available for content to kind of like only apply to one area or things like that. All of this comes from another subsystem. So that is the model subsystem. So this is typically where I will have stuff that defines kind of the structure of the project. And for LED projects, this will often be like where it builds the layout, figures out the position where every LED is, packages up that data usually into tops, although at this point I tend to do that with pops, but this predates that. There's a bunch of stuff in here, but the end result are these tops where there's like per pixel data that indicates, where everything is and so on. So for the position one, if you right click it and in the viewer do view as points, then it'll actually show those positions, basically as they are in the previs. The next area is the color subsystem. This is a client that had a very specific, detailed design brief, down to like hex codes for the specific colors that we were allowed to use. And so this component would collect those and make those available in different forms to areas of the project. Over in the rendering area, you can see that we've got those color things being pulled in here. I've got them as a bunch of constant tops that are the same resolution as the pixel map so that various things can pull those in. They are also set up with these expressions here to get colors from the parameters of that main color subsystem so that other things in this area of the project can reference those. So you'll see things like colors being used in RayTK portions of the project are pulling parameters from those constants and applying them to, content in the environment. After all of that, there is the output, which is basically where everything kind of goes out to other pieces of equipment. So in cases of like video-based projects, that will be where I'll have an output window or like a video device out or something like that. For DMX projects, it usually ends in, a DMX out. Again, this predates POPs. So if I were doing this project again now, we'd probably, do this workflow a little bit differently. But this is, taking that pixel map and then splitting it out and, rearranging it into DMX channels. And then there's a whole table of all the different IP addresses and things like that where each of those goes. Then there is the user interface, which has, a bunch of like parameter comps. Those are like a really easy way that you can just take a bunch of parameters and stick them into a UI without having to build out individual controls for each. So I tend to use that a lot for these kind of operator interfaces where like it doesn't need to look nice, it just needs to convey information and allow you to mess with the settings easily. Then I had those, status indicators that show, how close the current number of people is to the various thresholds and so on. I've got things that are pulling images from the sensors to display them in those little, debug displays. And then we've got some, graphs of the different values over time. Aside from that, there is this app subsystem, which handles things that are kind of like core to the functioning of the whole system. Often in projects that ends up just being like startup processes and things like that. I do also set up logging in there, but basically this is responsible for when the project loads, it goes through each of the subsystems and tells them to do whatever they need to do to get started up. So in some cases, that might mean like initialize all the sensors, or for the rendering, it might mean like make sure that each piece of content is ready to render by, requesting a frame from it at least once and kind of forcing it to cook so that it doesn't stall out, later on. Then there are components, which are things that are reused in multiple places throughout the project. Some of these are things that are like from the oak samples file. Others of them are just kind of little utilities that are used in various places in the project. And that's basically it. This is a kind of medium sized, I guess, commercial project. It's not at the level where you have like multiple different servers talking to each other and stuff like that. But it's also more complicated than just like a simple interactive piece. So this approach of kind of breaking things into subsystems tends to work pretty well, making sure to organize things and put things in the place where they make sense. If you need to get data from one place to another, you kind of use those up shortcuts and select operators to get them. So within rendering, there are, these selects that grab from that model subsystem and grab tops from that, and then has like kind of a local copy or reference to it within this subsystem so that things can reference that easily. And that's about it for this one. I hope this was helpful. This is a little bit of a new format for me. This is kind of unscripted, just sort of like going through existing stuff that I've already built out. I have a lot of other projects that I might do walkthroughs of. Generally, they tend to follow this kind of structure where you've got, a bunch of subsystems that interact with each other. Every project's needs are different. So sometimes things get customized in different ways. But generally, this is how we tend to build out these commercial projects. So hope that was helpful. And let me know in the comments whether this approach makes sense, whether this is something that you use, or if you have like a totally different way of doing things. I'd love to hear about that. Also, if you have other topics that you want me to get into or areas of this that you want me to get into more detail about, just let me know and I'll cover them when I can. Also, if you want to support me making more of these, consider subscribing to my Patreon. It will get you access to tutorials a little bit early and some file downloads and Discord and things like that. And I'd like to thank my existing Patreon supporters. It means a lot to me that you find my work valuable enough to support like that. So thank you. Thanks for watching, and make sure to like and subscribe and comment because I like getting comments. Bye.